let's look at a project. Let's see how the project is defined and in essence what it contains. So I'm going to open up one of our projects, and let's open up projects called Tiltbox. And what I'm going to do is open up that world file. And the world file I'm going to open up is full spheres. And in essence, this allows me then to open up this. And now we can look at how the code is, this world file is structured to define a project. So this is how we define, in essence, a problem. So we have a section here that's called model selection. And this allows us to select the contact sort of models that we have and what do we want to enable or disable. So in this case, we have a normal contact model, a linear spring dash, tangent contact model, linear spring dash, rolling contact model, R velocity damping, so that's rolling velocity damping, so damping is proportional to the rotational velocity, so rolling velocity, rotational velocity damping. Cohesion contact model, in this case, is none. Okay. Then there's, in essence, time steps that we can define. There's 1e minus 5, so if you make it less, it will run faster, but because of the explicit times integrator, it can also become unstable, depending on the material parameters. Then there's, in essence, world objects that we define, and we see, in essence, there's a name box square. There are particle objects defined, so there's a sphere 005 with this particle name. There are volume objects. There are then simulation set up here, where we define the total time of the simulation, the force field, that is the gravitational acceleration, particle rotations, whether it's on or off, velocity limit, valid zones. Then there are some broad phase parameters in this DEM simulation, so that allows us to see how to resolve grids for our broad phase, to identify whether we should check for the detailed contact or not. There's initial particle setup here, and that allows us to say how the particle should come into the simulation. This could also be read from a file if they are predefined. We have some output options here that allows us to define what we see in terms of output. You'll see the display is true, type bin 0.25. This allows us then to see the OpenGL frame of the code. That's also, that allows us then to look at that. And then there's some other parameters and stuff associated with this section here. So that's in broad how the format of the world file looks. So this is what it boils down to. I'm going to focus for now on the world objects, and I'm going to focus on the particle objects, so that we just understand what this box square in sphere 005 implies. Okay. So if you go into the project and you go into surface objects for that tilt box, what you'll see is there's a .wobj file. I'm going to open it up and show you this file. So there's a box square .wobj file in that directory, and then that contains, in essence, that box in which we see the particles are falling, and that's the definition for that box square. To understand what, maybe I'll just quickly highlight there, and to define that, it's quite simple. We can define the vertices, and then we can, from that vertices, define surfaces that makes up each of those polyhedral surfaces. In this case, they're all 4 nodes, but it allows us to make up that planar objects. That defines the wall. Okay. Then there are the particle objects, and we remember this is the particle objects here. We saw sphere 005. So under the directory of Tiltbox, there's a directory called particle objects. If you go into that one, you can open up the sphere 005 P object, and there's the definition of that sphere 005. So there's, in essence, a version number. Type is a sphere. There's a name, steel ball. That's steel ball is essentially just the name of the given to this to this type of particle. It's not being actually used at all, but it just allows you to, in the files, keep track of what's going on. There's the geometry specification, and then there's essentially the material file, AL poly. And so if you go into Tiltbox, there's that materials, and if I open up AL poly.mat, so this material file is a .mat file. If I open that one up, then in essence I get my material specifications. So I have density, coefficient of restitution, static and dynamic friction coefficients, stiffness parameters for tangential and normal, and rotational parameters. And these allow for, there are various ways we can define these parameters. This is just a stiffness based definition that's illustrated here. Okay, so that's in short what that boils down to. So if I go back to filled_spheres.world, in essence we understand where these things come from and how to control at least some of those parameters of the particles and of the world. Okay, so that's in essence this world. Let me just make sure if I highlighted that. This box square, we'll see at the model at the end here. There's also the material file wall. So if we go and open up that wall one, we can see that we can define for that wall its own essential material parameters that we have. Okay, so that's in essence what that allows us to do. Great, so that's just to get the ball rolling on understanding, just broadly speaking, what the world file is all about.